Okay, the Unit 7 Geometry Test Review. This is for Chapter 6, 6.1 through 6.7 on Similarity. In problem number 1 here, I have a rectangle which has a length of 80 and a width of 20. I'm asked to find the ratio. Ratio is just a fraction comparing two values of width to length. So I compare the width to the length, and then I reduce, becomes 1/4. Number 2, I have the interior angles of a triangle, and I have a relationship. They relate to each other as 2, 3 to 4. 2, 3 to 4. So this angle should be twice the size of this, as that relationship 2 to 4 implies. Since I don't know the measure, I use the unknown quantity x, and I know that all three of them, 9x's, will total 180 degrees. Divide both sides by 9, and x equals 20. I substitute that back in, and I have angle measures of 40, 60, and 80. Similar situation number 3. The only difference is the angle relationship has changed. It is now 5, 6 to 7. Again, I don't know the measure, so I'll use the unknown value of x. 5, 6, and 7 is going to be 18x, and that totals 180 degrees in the interior of any triangle. Divide both sides to solve, and x is 10. Substitute back in, and I get 50 degrees, 60 degrees, and 70 degrees. The geometric mean in number 4. Geometric mean is simply the product and then square rooting. So in this case, I have 67 times 7, and I take the square root of that quantity. This works out to approximately 21.66. I have 25 times 9, square root that quantity. This one works out to 15. 9 times 6, square root it, we get approximately 7.35. And it does ask you to round to the 10th place, so that would round to 7.4. This one to 21.7. 8 times 2, square root it, and I get 4. So geometric mean, simply multiply the two terms and then take the square root. Solving the proportion down below here in number 8. To solve our proportion, we simply cross multiply. So I get 5x equals, now I do need to distribute the 4 to both terms. That's 4x plus 6 times 4 is 24. Subtract 4x's from both sides. I'm left with x equals 24. Same thing here. I cross multiply on number 9. I'm going to get 50x plus 10 equals 18 times 3, which is 54. And then the 3 to the 6 minus 18. I then add 18 to both sides. Subtract 50x's. I'm left with 4x equals 28. Divide both sides by 4. And x is equal to 7. So proportions, we just cross multiply and divide. Given that segment DE is parallel to BC, because of that, I know that it splits the segments or the sides of this triangle proportionally. So 25 to x is the same, equivalent to 20 to 8. So I set up that proportion. If you like, you can reduce here, simplify the math. 20 over 8, 4 goes into both. That would be 5 over 2. Cross multiply, I get 5x equals 50. Divide both sides by 5, and x is 10. Number 11, when I have an angle bisector, how it splits the side across from it is proportional to the other two sides. So x to 8 is equal to 4 to 4. I should note this is 1 and that x will be 8, but we can certainly cross multiply. Divide both sides by 4, and x is 8. And over here we're back to essentially the parallel concept again. If these are parallel, then I can set up a proportion. 18 to x minus 4 is equivalent to 15 to x minus 5. We cross multiply to solve. I get 15x minus 60 equals, so over here, 18x minus 5 times 18 is 90. I then rearrange, subtract 15x, add 90, and I'm left with a positive 30 equals 3x. Divide both sides by 3, and I get x is 10. In 13, I have two polygons. I'm asked to write a similarity statement if they are indeed similar. In this case, I have a triangle. If you need to draw a picture, it would certainly help. So I have two triangles. We'll call this R, S, T, and this one would be U, V, W. Are they similar? Well, RS is going to be 10. R to T is 6. I know that R is 40. In this one, I have UV is 20, UW is 12, and the angle U here is 40. So I know that my angles are congruent. Then I look at the corresponding sides, and I set up a proportion. So 10 is to 20 should be the same as 6 is to 12. Indeed, they are. These both reduce down to 1/2. So triangle RST is similar to triangle UVW by the side angle side congruence theorem. I abbreviate with, similar with the similarity symbol and then THM for theorem. And down below here, I have two triangles. I need to find the value of the variables that make them similar. So I just set up a proportion. 15 is to 5, as 6y is to 10. Cross multiply, I get 150 equals 30y. Divide both sides by 30, and I get y equals 5. So the value of y is 5. And then to find x, I can do the same thing with another proportion. And as I set it up here, I can say 15 to 5 as 30 is to x. Cross multiply, I get 15x equals 5 times 30, which is 150, and x equals 10. Okay, over to number 15. Well, if these are oriented in the same position, I see here that x equals 76 degrees because corresponding angles in similar figures are congruent, corresponding side lengths are proportional, and then I set up a proportion comparing these corresponding parts, and I can say 4y minus 2 is to 12 as 21 is to 14. Then I cross multiply and solve. 21 times 12 okay, 21 times 12 is 252 equals 14 times 4, which is 56y minus 28. Okay, and then rearranging, I add 28 to both sides. So 252 plus 28 is 280. And I divide by 56, and I get y is 5. Number 16 down below. If these two figures are similar, all I need to do is compare the corresponding parts. 20 to 25, 16 to 20, 12 to 15, 24 to 30. So I set those all up. 20 to 25, is that equivalent to 16 to 20, as 12 is to 15, 24 to 30. And when I reduce all these, I find that they all equal 4/5. That would be the similarity ratio. And then I can write my statement, FGHJ is similar to ZYXW. 17. On a blueprint, the scale indicates 8 centimeters to 12 feet. What's the length of a room that's 13 centimeters long and 16 centimeters wide? Well, what I care about is the length. So if I know that the blueprint indicates 8 centimeters on the blueprint to 12 in real life, then that would correlate to 13 in the blueprint to x in real life. When I cross multiply, I have 8x equals 156. Divide both sides by 8. And then x is equal to 19.5 feet. In 18, if I label the sides, DC is 2, WZ is 43, and A to D is 4, then I compare the corresponding parts. AD to WZ, DC, and I can find ZY, or YZ. So 4 is to 43, as 2 is to our unknown. Cross multiply, and then divide by 4. And I end up with a solution of 21.5. So x, or YZ, is 21.5. If I need to find the measure of angle D via the markings here, I know that angle F is equal to angle C. They are congruent, so this is 57 degrees. As is angle B and E with those 2 marks, this is 58. And because I know that all 3 of them must add to 180, I know the remainder, angle D and angle A, is 65 degrees. Okay, looking at the picture here. Now you need to be aware of the markings here. These tick marks indicate that these are congruent. So if this is 125, this is 125, and I have the entire length of 250. If this is 115, then this is 115, and so the entire length is 230. I can also separate this out into 2 triangles if visually that's going to help. I have a smaller triangle here representing the height of the tree, and then the larger representing the height of the building. This would be 200 feet, 230, 250, so I know these 3 sides. This would be 125 and 115. Since I need to find the height of the tree, I just pick some corresponding sides. I'll take those 2, the hypotenuse, compared to my unknown tree height there, and 200. So 125 is to 250, as our unknown x, tree height, is to 200. I can reduce here, recognizing that this is 125 to 250 is 1 to 2. So I see that 2x equals 200, divide by 2, and x equals 100 feet. Similar situation down here below in number 21. I just compare corresponding parts. 15 to x, height of the tree to the height of the girl, would be the same as the shadow of the tree to the shadow of the girl. Again, I recognize the ratio here, 24 to 8 is 3 to 1. So 3x equals 15 when I cross multiply, and x is equal to 5. Finding the value of x, I do this by simply setting up a proportion, and I compare the corresponding parts. So 3 is to 5, as 4.5 is to x. I then cross multiply and solve, and I get 3x equals 22.5. Divide both sides by 3, and I have a value of x that is 7.5. I then need to find the perimeter of RST, so I need to set up one more proportion to find the missing side length. So I can do that using the same 3 to 5. AB is to RS as 6 is to RT. So my new unknown, I'll call this one y. And I have 3y equals 30 divided by 3, and this length would be 10. So then when I need to find the perimeter, I simply add up. I have 15 plus 7.5. The perimeter is 22.5. Okay, in 24, we learn that when lines are parallel, it segments the sides of the triangle proportionally. So I know that 12 to 36 is the same as, or proportional to 9 to x. So 12 to 36 is equal to 9 to x. I cross multiply. I can reduce this a little bit. I know that it's 1/3. I cross multiply and I get x equals 27. In 25, we know that an angle bisector segments the side opposite it proportionally to the two sides. So I know that if I set up the proportion, x plus 3 is to 12, as x is to 8. So with that proportion, I can cross multiply and solve. And I get 8x plus 24 equals 12x. Subtracting 8x from both sides leaves me with 24 equals 4x. Divide both sides by 4, and I know that x is 6. In 26, to determine, this is the converse triangle proportionality theorem. So if 2 to 1 is the same or proportional to 3 to 1.2, then BD is parallel to AE. So is 2 to 1 the same as 3 to 1.2? I see that this is twice as much. This clearly is not. So BD is not parallel to AE. And I do the same thing here. 3 to 6, is that equal to 4 to 8? These both reduce to 1/2. So I know that A to E is parallel to BD. And our triangle similarity postulate and theorems, I have angle, angle, side, 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 and side, angle, side. In order to determine if these two triangles are congruent, I see that these lines are parallel, which leaves me with alternate interior angles, and I know that I have vertical angles here. So I could say that triangle DEH is similar DEH to FGH by the angle-angle similarity postulate. And in the second one here, I see these are both right triangles, corresponding sides. So I can compare 8 to 16. I can compare 6 to 12. So is 8 to 16 the same as 6 to 12? I see that both these are 1/2. I have the included angle. So I could say triangle ABE is similar A to B to E as CBD. And that would be by the side angle side similarity theorem. Number 30, I certainly know that J is congruent to J. It's the vertex in both triangles. And because these lines are parallel, I know that these corresponding angles K and M are congruent. So triangle LJK is similar to triangle LJK to NJM by the angle-angle similarity postulate. And again here, I know that certainly this angle M is congruent to itself. This side is congruent to this side. So if I needed to set up values, this would be a 1-to-1. I could call this 1 and 2, so this would be 1 and 2. So I know that in terms of the relationships of the shapes, this triangle would be 2 to 4 would be the same as 1 to 2. So I know that these two triangles are congruent. So we'll say DPM is similar, not congruent. DPM to LNM by side angle side. Similarity theorem. THM to abbreviate theorem. Okay, in 32, if I'm going to find the missing sides, we need to set up several proportions. And at this point, these are very similar to the bonus questions on the test. So I'm going to go ahead and leave those blank here. If you want to check yours, you can compare it to the online review key on the website or on Ms. Noriega and Ms. Carranza's outreach page.